So good afternoon. So this is differentials. Basically, we'll be dealing with applications of in word problems, some approximations, estimations of errors. So what are differentials? For example, let y is equal to f of x represent a function that is differentiable on an open interval containing x. Therefore, the differential of y denoted by a differential of x denoted by dx is any non-zero real number, and the differential of y denoted by dy is this one. Dy is basically f prime of x dx. So if you can recall, isn't it that if I ask you, the derivative of y with respect to x is basically f prime of x. This is what you call the derivative. However, if you transpose the dx and multiply it to the other side, this becomes a differential. So in many types of applications, the differential of y can be used as an approximation in the change of y. So you recall before I said the delta y is actually a capital letter D, the triangle there. So for example, when you say delta T or change in temperature, you know that that's temperature 2 minus temperature 1. For example, delta distance is distance 2 minus distance 1. However, if, for example, if I say, what's the change in temperature from 10.5 to 10.6? That's 0.1 degrees Celsius change, right? Whereas if I say 10.5 to 10.51, that's 0.01 degrees Celsius change, right? And if, for example, the change is really, really small, we say that the delta y can be approximated and written as dy, the small letter d. So find the differentials of the following. So for example, number 1, how do we get the derivative? Isn't it that before, in solving for the derivative, we say dy over dx is 2 times 2x minus 3. That's the only answer. But now, it has to be 2 times 2x dx minus 3 dx. And then the 4, it becomes 0, right? So here, that's actually 4x dx minus 3 dx. Or if you factor out the dx, it's simply 4x minus 3 with a dx. And then if you look, the derivative of y with respect to x is simply 4x minus 3. Am I correct? So number 2. This one, we will apply the power rule. So dy is basically 4 over 5 x squared minus 3 to the 4/5 minus 1. And then the derivative of the inside is 2x. But then since actually we're looking for the differential, so it has to be a 2x with a dx. So this one, 2 times this is 8x 5, and then this one will just be a 5th root of x squared minus 3 dx. So this is your dy. All right. Let's try number 3. You're seeing an arctangent. So for arctangent, we apply the arctangent formula. 1 over 1 plus y over x quantity squared. And then the differential of that. So that is low, d high, but then instead of just a dy over dx, it will just be a dy minus high, d low, so it's this one, over low squared, plus that's arc sine. So 1 over the square root of 1 minus x over y squared, and then the differential of the inside, which is low d high minus high d low over low squared. The differential of 1 is 0. Last one, let's try number 4. Cosine of the square root of y squared minus x squared. And then the differential of the square root, which is 1/2 x squared minus y squared to the negative 1/2. The differential of the inside, which is 2x dx minus 2y dy. We're done. For the second portion, it's an arc cosine, so it's negative 1 over square root of 1 minus ln y over x quantity squared. And then ln, so 1 over y over x, right? And then that one is low d high minus high d low over low squared is equal to 0 because that's a constant. Next. Okay. So when the delta x is small, the delta y can be approximated by f prime of c delta x. So delta y has the formula of f of c plus delta x minus f of c. If, for example, delta y here is approximated to be dy, the delta, as I've told you before earlier, that's a bigger change. The d is a smaller change. So here, y2 minus y1 is approximated to be the f prime of x dx. Isn't it that this one, yan yung kanina, the one I showed you, dy is actually f prime of x dx. Therefore, if you want to solve for y2, you can transpose y1, and this will be the formula. So I'll show you how. This one, you will try to approximate this, guys, as much as possible, of course, without the use of calculators. So I'll teach you how to do this using differentials. So earlier in our discussion, as I said, we say that delta y is basically y2 minus y1, right? And then we would want to approximate this. So this is approximated to be dy to be y2 minus y1. So y2 is actually y1 plus dy. And then what I would try to recall is this one, the subscript 2 is to be approximated. Subscript 1 is the exact. So what do I mean by this? Okay, let's go to the solving. Number 1, we'll try solving the square root of 4.1. So as I said, the y2 is equal to y1 plus dy. First, let's think of what the y should be, what the x should be. x2, of course, as I said, the subscripts 2 and 1, for the 2, that is the one to be approximated. The 1 is the exact. Okay, you'll notice that inside the square root, there is 4.1. What is the exact perfect square that we can, that we know of? Diba? Square root of 4. Therefore, the exact is 4. The one to be approximated, which has a subscript 2, is 4.1. And of course, dx is basically 2 minus 1. So this is 0.1. Okay, now that we have this, we'll be using that later on. It's up to us, guys, to think of an equation that would fit this. So for me, the equation would be this one. Y is equal to the square root of x. And then let's solve for the dy. dy, we know that is 1/2 x to the negative 1/2 dx. So we're finished with the dy. Now let's go to the approximations, guys. The square root of 4.1 is actually square root of x and the dy, but the dy is solved already. That's 1 over 2 square root of x dx as per the formula. Tama? And then we plug in. So when we plug in, square root of, we plug in the exact values, guys. For 1 over 2 square root of 4. And then the dx, we were able to solve that. It's this. You know that the square root of 4 is 2. This is actually 1/4 and 0.1. Kasi square root of 4 is 2 times 2 is 1/4. So 22 plus 0.25 times 0.1, right? So 2 plus 0.025. Can you please check using your calculators? If the square root of 4.1 is roughly 2.025, exact up to the third decimal place. Exact siya, up to roughly, if it's rounded. Diba? So we were able to approximate it. Now, let's go to another one. So the fourth root of 15. Again, let's go back. What should be the equation? Y is the fourth root of x. So what is x2? What is x1? What is dx? 1 should be the exact one. So the exact is 16. You were given a 15. Therefore, 15 minus 16, that's -1. So what is dy? dy, let's use the power rule. 1/4 x to the -3/4 dx. Okay, writing the formula, y2 is equal to, so basically what we're applying is the linear approximation, guys, plus dy. Therefore, y1 is basically the fourth root of x plus dy is 1 over 4 instead of that one. Sige. Okay lang. I'll just write it as an exponent. Okay, now that we have this, we can approximate 15, fourth. So that's fourth root of 16, 1 over 4, 16 to the 3/4, and then this is -1. The fourth root of 16 is 2, right? Plus 1 over 4. And then this one, 16, fourth root is 2, guys. Cube, that is actually 8 times -1. 1 over 4 is 25 divided by 2, guys. 0.125, right? 0.25 divided by 2 is 0.125 divided by 2 again. 0.0625 divided by 2 again. 0.0315. Am I correct? Times -1. So that means 2 minus 0.03125. What is the approximate, guys? 1.96875. So 1.96 approximately. Tama? Okay. Now, let's try a third one. Number 3. So in number 3, I gave you 1 over 9.99. We know that an exact one would be 10 kasi 1 over 10 is 0.1. So let's create an equation. x2, x1 and dx. x2 will be whatever you're approximating. x1 is the exact, so that means this is -0.01. So with this, the dy is negative 1 over x squared dx, right? Therefore, y2 is y1 plus dy. y1 is basically 1 over x. And then dy, let's just copy whatever dy you obtained. Okay, now let's plug in 1 over 9.99 is equal to 1 over 10 minus 1 over 10 squared and negative 0.01. So this is actually 0.1. 1 over 100 is 0.01, and then another 0.01. 0.1 plus, so it's 1. Is this correct, guys? 1 over 9.99. So number 4, 8 all over the square root of 3.95. So in here, I can see that the best equation would be this one, right? So what is my x2, my x1, and dx? Can you answer, guys? What's the best x2? The exact one is an x1. The one na may underscore na 2, ay the subscript 2, is always the one you're approximating. So the one you're approximating is 3.95. This is the 4. Okay? Ito, always remember this. But the subscript 2 is the one to be approximated. The subscript 1 is the exact one. So this is negative 0.05. Okay. What is the dy? I don't need the 8. Let's move it out. So that's negative 1/2 x to the negative 3/2 dx. So this is negative 4 over, that's basically x squared of x dx. Therefore, let's approximate 8 over the square root of 3.95 is 8 over the square root of 4 minus 4 over 4 square root of 4 negative 0.05. Tama? So let's try to cancel what we can cancel. That one, that one. This is 8 over 2 is 4. Minus minus becomes plus. That's 1/2. So that's 0.5 times 0.05. 0.025. Am I correct? So the answer is approximately 4.025. Okay. Yep. So basically, that's how to approximate. So I'll teach you this one, but then I'll just answer number 6. In this event, you have to remember, if I ask you, what is the sine of 30 degrees? You will say 1/2. What's the unit of that 1/2? It does not have any units. So let's just say radians. So what we do here is, for sine of 30.1 degrees, y is equal to sine of x. X2 is equal to 30.1 degrees. X1, sorry, it should be a subscript, is 30. Dx is 0.1 degrees. But then since sine of 30 is 1/2, the dx, let's convert this to radians. That for every 180 degrees, there is pi radians. So the dx in here, 1,800. Therefore, you know that the dy is cosine of x dx. So let's approximate. y2 is y1 plus dy. y1 is basically sine of 30 plus cosine of 30 times dy. The dy is pi 1,800. So this one, you know the answer, it's 1/2. This one, you know that the answer is the square root of 3 over 2. This one is pi over 1/8. 1/2 plus square root of 3 pi over 3,600. Okay, so basically, guys, that is the approximation. Let's go to the propagation of error. So in approximation, you can see there are errors. Yes, it's not exact. It's okay. We're just approximating. For the propagation of error, also known as error estimations or error in computations. So the amount by which the computed or determined value differs from the true value. For example, dy is what you call the error in y. We know this. Dy over y is the relative error in y. So, for example, let's just say you bought something. It says that for every 100 grams, it costs 100 pesos. So you know that it's 100 grams because the weighing scale said so. However, you notice that when you went home, it's not actually 100 grams. It's actually 98 grams. Therefore, may something wrong with the scale at the store, probably. So the error in the scale is what? You were given 98. So probably for every 100 na measurement, 98 lang na measure niya. So 2 yung error. Right? So 2 is the error in measuring the weight. So what's the relative error? 2 divided by yung actual na weight, di ba? 2%. 2 divided by 100. So in here, guys, for example, you're given basically a block, a square block, wherein the base, it's B and B, and then this is the height. So you'll be asked to solve for probably the error in solving for the volume, error in solving for the surface area, something like that. So let's try. In here, this already has an answer. What is the approximate percentage error in the volume and surface area of a cube of edge 2 feet if an error of 1/8 inch is made in measuring the edge? So what's the application of this one, guys? For example, we have a classroom. Let's just say the classroom is 10 meters by 5 meters by 5 meters. So 10 meters long, 5 meters wide, and 5 meters high. So if I ask you what is the exact volume, you can solve for the volume. Am I correct? But what if I painted or I placed a wallpaper on the walls and ceiling, for example? Wall and ceiling had wallpapers. The floor, of course, did not have. Pero the wallpaper has a certain thickness. Let's just say 0.1 inch. Will it affect the volume, the total volume of the room? Yes, because the original volume is just length times width times height. Now it's length times width times height, but then with a bit of a deduction because of the wallpaper's thickness. Am I correct? So it's similar to that. So let's try solving. So in this case, the error now in solving for the sides is 1/8. So the error in solving for the side is 1/8 inch. Okay? Feet and then inches. So let's try. Surface area of a cube is 6s squared. The volume of a cube is s cubed. The problem here is this is feet, that is inches. So maybe if you want, we can change this to inches. You can change the top one to inches, or you can change the bottom one to feet. It's up to you. If I change this is actually 24 inches, right? So you're asked to solve for the error in the percentage error, yeah? Am I correct? So let's solve for DSA first. So this is 12S ds. The dV is 3S squared ds. So let's plug in 12. And then this is 24. This is 1/8. So this is 36. But change in area. So therefore, since it's in inches, it should be inches squared. The dV, 3/24 squared times 1/8. So cancel isang 24. What's 24 times 9? 216. This is inches cubed. You're asked here in volume, percentage error in the volume. So percentage. Therefore, DSA over SA times 100, dV over V times 100. Take note that the actual V is 24 cubed. This is 6/24 squared. 36 over 24 squared times 100. 1.041%. The other one is 216 divided by 24 cubed times 100. How much is this? So I think we have the answers. 1.56 and 1.04. Okay. Next. How big is the Earth? Was the teacher's question in her science class. So this cross-eyed wise student went to the globe at the corner of the room and wrapped a tape measure around it along the equator. He noted down the circumference is 25. From there, he went on to compute the volume. If the true circumference of the globe was 27 inches, then his computed volume is erroneous. How much was the error in the volume? Okay, so it's this one. So it says that the circumference that he measured, so C2, is 25 inches. The actual circumference, C1, is 27 inches, right? So the differential in C is -2 inches. Tama, no? 25 was the observed, but then the actual or the exact is 27. Therefore, C2 is 25, C1 27, DC is -2. So, error in solving the volume. The problem, guys, is we don't know the radius, but we know the circumference. So look, you know that the formula for the volume of a sphere is 4/3 pi r cubed. The problem is I don't have the r, but I know that the formula for the circumference is 2 pi r. Therefore, r is basically circumference divided by 2 pi. So if I would replace this circumference divided by 2 pi cubed, so that means this is 4/3 pi c cubed. This is 8. This is pi cubed. And then let's simplify. So that's 2. Cancel. That's 2. Therefore, this becomes c cubed divided by 6 pi squared. So far, can you follow the formula for the volume? All right. So let's solve for the differential in volume. The 6 and the pi squared are constant, so I will move that out. This one becomes 3c squared dc. So let's try canceling out what we can cancel. That and this one. So that's 1 over 2 pi squared. The c that we will plug in is 27. The dc is -2. So you'll notice we can cancel the 2 and the 2. What's 27 squared, guys? So -729 over pi squared, and then inches cubed.